All right, so let's start thinking about this problem. So we have the region. So we're going to consider the inside of R1, which is 3 sine theta, and also outside of R2, which is 1 plus sine theta. So the first task is to plot these two polar equations in the same graph. So have your TI-84 ready, and please start plotting these two guys in the same graph. And choose your theta min to be 0, theta max to be 2 pi, so that you get the whole picture. And we can pause the video anytime right now to do that, and please do it. And if you sort of like look what you're going to have, this is exactly what you're supposed to see in your end, okay, in your calculator. So it says, let's see, let's go back here. We have the inside of R1. Inside of R1, R1 is the blue one, so let me just also label them here. This is R1 and this is R2. Inside of R1 and outside of R2. So we're going to still stick inside of R1, that's the circle, but it's going to be outside. So you have the crescent shape here, the crescent region. So we're going to find the area of the crescent here, okay? So to be able to find that, see that this area is enclosed by the points here. So like for the theta angles, looks like it's pi over 6 on the right and 5 pi over 6 on the left. But you want to find those theta values analytically, and please have your table as well, like the way I did here. It used to be like I was writing this by hand, but since we have two curves, it takes too much time. So I decided to put the R1, R2 sample values on the table, and I just made this from 0 to pi because here from pi all the way to 2 pi, we don't have any intersection going on. So, but for your own reference, you can keep putting the sample values starting from pi all the way to 2 pi, okay? And I can visually see that 5 pi over 6 and pi over 6 provide us the same R values. That's why you have the same, we have the intersections happening at those points, okay? So let's try to find those points by setting R1 and R2 equal, okay? So 3 sine theta equals 1 plus sine theta, okay? And solve this for theta, right? And at this moment, have your unit circle ready, because we're going to sort of like refer back to that. And now I'm going to subtract sine theta from both sides of the equation so that I have on the left 2 sine theta and on the right I have only 1. Okay, that's good. And sine theta out of this is going to be 1/2. Okay, 1/2 is a known number for the sine value, and that's why you should go back to the unit circle rather than looking at arc sine, which you can, but your calculator is going to spit out only one value. Okay, so sine is the y coordinate of the points on the unit circle, and we're looking for 1/2. There we go, 1/2. Okay, here we go, 1/2. Okay, we have two different instances where sine achieves the value of 1/2. These are pi over 6 and 5 pi over 6. So what I can do here is that I can go back here and write the solution down. We have two solutions, pi over 6 and 5 pi over 6, and see how the unit circle helped us to grab those numbers in one shot. Okay, if this number was kind of like a weird number or a number coming with decimal places, then you would have to rely on arc sine of that number evaluated by your calculator. But since it's going to be on one value, so you would have to go back to the unit circle again and see the equivalent version of that. Because if I have only pi over 6, for example, coming out of my calculator, and I'm going to look for another theta value for which it's 1/2. So I was going to take the symmetry of that point, and I would end up being right here. And that symmetry in this case would be about the y-axis, because we still have sine values to be positive. Sine value to be positive 1/2. So that only happens about x-axis, okay? And the symmetric version of that angle is essentially pi minus pi over 6, that's 5 pi over 6. Okay. So anyway, this was a side information that could be helpful in the future for you. So let's go back to this graph. We know that intersections happen at 5 pi over 6 and pi over 6. Okay, let me just label those. So now I'm trying to find the area right now. Okay, so what happens is that if I start from pi over 6, let me just clean up this and just talk about the area part of this problem. Let's say like I start from here, okay, and let's say I'm going all the way in this direction, and then ending up at 5 pi over 6. So what kind of area do I sweep through? Well, that area is going to be the full green region here. Okay, so you should be able to see that visually and convince yourself. Okay, so if I look at the area formula for R1, obviously, this is R1. Okay, starting from pi over 6, going all the way 5 pi over 6. And you can check that the direction is this way. Okay, you can check that, visually verify that. Okay, so then I get the green shaded area. Okay, so now let's think about R2. R2 is the purple. And starting from here, going all the way here. And if I sort of like, turn my, sort of like rotate my array starting from pi over 6, going all the way to 5 pi over 6, I'm going to sweep this area now. And the first green area minus the second green area is going to be the area of the crescent here. Okay? So essentially the second area, the green area here, is found by working with R2 and using the area formula for R2. And the first green area minus the second green area is going to take me to the yellow region and its area for that. Okay? All right, so why don't we start? All right, here we go. The first green area is 1/2 integral from pi over 6 to 5 pi over 6, r1 squared d theta. And the second green area I mentioned a few seconds ago is 1/2 pi over 6, 5 pi over 6, integral from pi over 6 to 5 pi over 6, r2 squared d theta. Okay. So I'm going to do the calculations here, and eventually I'm going to find the area of the yellow region. Okay, so and the rest of this is just calculation of this integral here. So in fact, two integrals. So let me just write them explicitly. Okay, so here the first one is going to be 3 sine theta squared, and the second one is going to be R2 is going to be 1 plus sine theta, so the square of that is this, okay? All right, so two different indefinite integrals, so let's just do them separately here, okay? So I have integral of 9 sine squared theta, d theta, and you have 1 plus sine theta squared d theta, okay? And for this one, I'm going to use the power reducing formula for sine. I'm going to pull the, in fact, let's pull the 9 out here, okay? And use the power reducing formula, 1 minus cosine 2 theta over 2 d theta. And this is integrated as 9 over 2 theta minus 1/2 sine 2 theta plus c, okay? And for this one, we have to expand this whole thing out. And for sine squared theta, I'm going to use the power reducing formula as well. So let me just replace that by 1 minus cosine 2 theta over 2. Okay, and now we can integrate in one shot. Theta plus, let's use the whites again. Theta plus minus 2 cosine theta plus 1/2 theta minus 1/2 sine 2 theta, and plus c. All right. In the next slide, what I'm going to do is I'm going to grab those antiderivatives, okay, and use them towards evaluating the integrals at the top. All right. All right. So I copied everything up there, and now I'm going to erase the bottom part. You can pause the video at this moment, and you can just copy the mathematics over there. I'm going to erase the bottom part. All right, so let's plug in 5 pi over 6 in the first one. So 5 pi over 6 minus 1/2 sine 5 pi over 3 minus 9 over 4 pi over 6 minus 1/2 sine pi over 3. This is the first one taken care of, right? So far, and then let's do the second one. I'm going to use a different color so you can see the difference. So I'm going to put the second one right next, okay? Minus 1/2 3 over 2 theta, okay? 15 pi over 12 minus 2 cosine 5 pi over 6 and minus 1/4 sine, yeah, 5 pi over 3. So minus 1 over 2. I'm going to put a curly bracket over there so I'm not going to confuse myself. Minus, I'm still continuing, plugging in the lower limit. So pi over 6, 3 pi over 12 minus 2 cosine pi over 6 and minus 1/4 sine pi over 3. Close the bracket, close the curly brackets, okay? All right, the rest is just evaluation, and try to use the exact numbers, and I won't do that here because this video is already too long, okay? Go back to the unit circle to grab the cosine of 5 pi over 6, 5 pi over 3. We have all of them listed here, and please have it ready, and I'm just going to write down the result here, okay? So the result here is, let's just put at the top here, so this is equal to just pi. Okay, after you simplify everything, so the area of the common region has to be just pi, okay? Common area, all right? So this is equal to pi for your own reference. All right, this completes part C. And we have only one part left, and I'll see you in the next video to show you like what I'm going to do for part B. All right, bye.